any company that you're working for, you probably have customers. And one of the techniques that you want to use there is to cluster these customers into high value, medium value, and low value customers so that you're able to target them with specific marketing or email messages, etc. And a very popular technique is K-means clustering, which is sort of like a unsupervised learning. So you just throw a bunch of data into it and you just tell it how many clusters you would like, and it gives you back that many clusters of customers or any other application that you're using this for. So we are going to use that in today's video, and let's first work by creating a synthetic data, because there's no real world data that I want to work with for just these simple examples where we just want to get intuition for these techniques. This synthetic data is good enough for us. So I'm going to start by importing NumPy and pandas. Let me just open up my console and let's look at how this data looks like first. I'll just open this data frame up and you'll see that we have these customers who are ordered over here, and they have certain number of purchases and purchase amount associated to them. And similarly, we have customers 10, 1, etc. So we have a lot of customers which with associated purchases. So let's work on customer segmentation. And in this simple example, we just want to cluster our customers into 3 segments: high value, medium value, and low value. And so this is the K-means clustering algorithm that's already there in scikit-learn. So you can look at the documentation that it gives us, and the parameters that you're going to give it are the number of clusters that you would like. And we'll try to get an intuition of how this works under the hood. But for now, let's just run with this and see what we get. So I'll just run that and I'll say K-means clusters, number of clusters is 3 for me. And I'm just going to append another column to my already existing data frame over here saying cluster. And then we are just going to do a fit predict on it. And let's see what this gives us. So now when I run that, you see an additional column was added over here where we have the clusters. So this customer is cluster 2, this is cluster 1, and cluster 0, and so on. But it's kind of hard to look at this data in a tabular format. So let's plot this out and see what we get. So I'm just going to bring in matplotlib, and we're just doing a scatter plot over here. And let me just run all of this. And you'll see we have a plot which is kind of giving some information to us. And of course, this is all synthetic, the generated data. So we can't really expect much from this, but we are able to see that these were categorized into 3 clusters and they're colored according to the cluster. And this is the purchase amount. So under 400, this is the cluster. 400 to perhaps 700, this is another cluster. And then this is like high value customers, if you will. So you can of course do the same using matplotlib express as well. And if I open this up, so you'll see there are these customers who have been associated to one of these clusters. And you can see all of this here. If I hover my mouse over it, so you'll see this is customer ID 90, purchase amount 790, cluster 1, and this is cluster 2, and this is cluster 0, if you will. So these are the clusters that we were able to see from the Plotly Express. Now let's work on getting some predictions, right? So let's say if you want to look at customer 20 and we want to find out if this customer belongs to a particularly high value customer, maybe get these details out and maybe do a marketing campaign for this customer. Let's see what we get. So we just initialize a simple function over here, and we're just passing it the customer ID, and we'll get the customer ID and then find out what cluster this customer belongs to. So we're just pulling out the cluster column from here and then just printing it out. So we'll say customer ID is 20, and let's print this out. So we'll say the customer 20 belongs to cluster 0. So we can run that same thing for customer 2 and see what cluster this customer belongs to. And this customer belongs to cluster number 2. And you can assign what cluster means, like in terms of high value, medium value, and so on. But this is really good. So by just doing one simple line of code, we are able to cluster all of our customers into different segments. And this would have been so much more tedious if we were to do it like a rule-based approach. But within this unsupervised learning technique, we are able to do this really well. And before we move on to the next technique, I want to give you an intuition of how K-means works. So I have some simple visual over here. So the K-means, how it works is initially it just assigns a cluster, and it can pick any random cluster. So imagine this was a data set, and maybe we pick out a cluster over here and over here. So this is how K-means would start. It just picks up random cluster centers, if you will. And then in the next step, it's going to move those clusters closer to where the values are. So maybe this cluster might come over here and this cluster stays there, and this cluster might go and center over there. So that's the next step, where instead of marbles, if you will, this was an example for marbles, but in our case sales. So we have customer A and customer B who are close related, so we can bring them over here and then here. So the cluster centers are actually moving now. And then finally, there are new clusters again updated. So maybe we don't need this cluster because we have a few here. So maybe this cluster can center around here, and all this cluster can come in here, and all these two can come in here. So we've kind of updated our clusters as we go along. And this is how k-means works. So it starts by initializing random number of cluster, which you specify. So if it's 3, it's going to create 3 centers. And if it's 5, it's going to do 5, etc. So this was good, but there is another technique which is also very popular. We call it as agglomerative clustering. And this is a technique which is similar to k-means, but does the same job as well. And we'll try to get an intuition of how this works before we move on to the code. So here, instead of k-means, where we start out with a defined number of clusters, which we specify, agglomerative clustering works by creating clusters to each data point. So imagine we have all these data points, let's say 1,000 data points. It creates 1,000 clusters to begin with. And it does merging, which are like closest together. So imagine we started off with these two, and these two are really close. So maybe we just create a cluster around them. So we are merging together instead of moving the centers. That's how k-means work. Here in agglomerative, we are trying to bring all these nearby pairs closer and create a cluster among them. So now we have A and B have been clustered and they've been merged. Next, we have a few other merges that happens iteratively. So maybe in the next case, we merge C and D, and here we might merge E and F and G and H and so on, until we finally get to the number of clusters which we have defined. So in our case, it would be 3. So finally, we would merge A, B, C, D, E, F, G, H, and I, J. So this is kind of the desired cluster that we get. So hopefully that gives you enough context into how k-means and agglomerative works. And let's just run through some code and see how all this works. So this is again implemented in sklearn. So we'll bring that, and similar to k-means, we're just going to initialize this clustering technique, and we'll do a plot after we've done our fitting. And it looks exactly the same. There's not much difference. So if I go back and forth, the colors have changed, but then the values are very similar. So this is k-means and this is agglomerative. So that was good. But then how do we decide which algorithm did well? So that's where we have some evaluation metrics. So for that, we have a technique called as silhouette score, and we can come in here and read what this does. So this score is calculated using the mean intra-cluster distance and mean nearest cluster distance. And the silhouette coefficient is a simple B minus A pi max. So there's a formula that gives us which clustering technique did well, right? So if you want, you can hover the mouse over it or go through documentation on it. But evaluation technique, this is one of them, which is quite good. And we just do a score on this. So we get the silhouette score function. To that, we are passing in the Y value or the purchase amount, and then the cluster, and do the same for this as well with agglomerative. So let's just run these two. So I realized we were writing some of these cluster variables. So I just split this out, and I've moved my clustering calculation up top over here. So this is where we would get a k-means clustering, and I can show you what we got over there. So this was 0.6025. So that was with k-means, and with agglomerative, I just moved it over here after the calculation. And with agglomerative, we're just getting 0.57. So in this case, at least k-means 1, because that's where the silhouette score is saying that's a much better clustering. So we can go with that, or you can keep on continuing with other techniques, do hyperparameter tuning, etc. But that is in a nutshell how you do segmentation, in this case, customer segmentation.